Hello again, this is Homero Arari, and this is part number 2 of chapter number 2 of statistical models. So this is an example that I brought and that I pick up from the references, and this is a paper that is talking about the estimation of occupational exposure to tetrachlorobenzopidioxine using a minimal physiologic toxicokinetic model. And what they're using is a linear model to estimate exposure to workers using limited input, but still observable data. So this is pretty much what we have talked before. And if you look at the way that they are presenting the information, these are all scattered plots, the A and C, and the line is crossing the points. And so according to this article, the exposure to this specific chemical can be modeled by the use of the information provided by this model, which is useful, which can be useful, but also could be a disadvantage because probably we are underestimating exposure to workers, and model is a great thing to use, but it has to be used carefully and has to be fed with good information. So good information that will finally provide good fit, moderate fit, or poor fit. And so this is a linear model this is an hypothetical linear model for the good fit based on information of air sampling in silica in construction work. And we can see that R squared is 1, so it's optimal, but this is as I said, hypothetical sampling. And this is a moderate fit. The dots are around the line. The line is in the middle of all the points, the observations. And then we have the final example of poor fit. And as you can see, the line and the points are really scattered, so it's not useful. So as I mentioned before, it is impossible to sample every single phenomenon and record its information. But at the same time, we need to collect enough information in order to represent an event, and that's where the usefulness of model comes, because we cannot keep sampling to know the reality. So models can help us, but doesn't mean that we have to stop to sample. So still we have to base all the information, and we have to feed and input information, real information, or several information in the models. So I'm going to show you now one example in our laboratory, and how do we use linear models. And this is the curve that the good fit linear model that I showed previously. And how this works is that the line provided me with this equation, and this equation is the model. So what I want to know is the concentration based on this information, and the information that I have is the information of the instrument, and I want to know the concentration. So basically in the reading, the instrument is 0.05. When I cut out 0.1, 0.3, and 0.5, I get a different concentrations of silica based on this concentration. So this is a model. I sample, but the model can help me to guide me to get an accurate number. So this is This is an example of a statistical model. And then, just to finish this presentation, I want to make a little quiz. It's true or false. And number 1 is, all the models represent observable and unobservable data. And you have to answer, please, this. And the second question is, models depend on the information which they were built from. You have to answer true or false to these questions. Thank you very much for your attention, and have a good day.